Welcome to Teddy Physics. So today we are going to discuss about NCERT Class 10 Chapter Electricity Inner Exercise 2. So the first question is, name a device that helps to maintain potential difference across a conductor. So we know the device is nothing but a cell or a battery. So any device like cell or battery can maintain potential difference in a circuit. We will write here. So any device like a cell or battery can maintain potential difference in a circuit. Simple more, we seen already so many circuits. So I'm going to draw a circuit here, like this is a circuit I'm going to draw. So it is having a resistors like R1 and R2 like this, and in this circuit, if I want to complete this circuit, I need a voltage source so that it can maintain a potential difference here. So I need a voltage source, so I'm going to take a cell or a battery which is noted like this. So this, for example, if it is 9 volts, indicate that the potential difference in the circuit here from here to here, it is 9 volts like this. So R1 and R2 is the resistors, and this we can say it as potential difference in the circuit. And we'll go for next question. What is meant by saying that potential difference between 2 points is 1 volt? That means what more? It means 1 joule of work done in moving 1 coulomb of charge from one point to another. So for example, we are having a same circuit here, like this is a circuit we are having here. This is a circuit. Okay, let me take this as a voltage V, and this is a point A and this is a point B. Now from point A to point B, okay, so this is what is meant by saying that potential difference between 2 points is 1 volt. That means what? Voltage of A minus voltage of B is equal to 1 volt. This is what he is saying. So at this voltage minus at this voltage, potential difference between 2 points is 1 volt. Means what? Means, so we need to, this battery need to do some work for moving charges. What it is doing more here, the positive ions will get reflected. I mean it will move on like this, and it will come to attracted by this negative side of the battery. So positive side pushes and negative side pulls like that. So it always pushes and it is always pulling, pushes pulling like this. So the battery is doing some work in pushing the charges, right? See here this battery, this terminal is doing some work in pushing the charges, right? So how much work has to do this battery for pushing the charges from here to here? Okay, here the potential difference between two is 1 volt. They given that this is 1 volt, meaning how much energy, how much work it is doing here. Okay, that is what. So here we can say that from the formula we already know. So work done is equal to potential difference into charge. The same formula I am going to rewrite like this. More potential difference I will be keep here, but charge I will send here. So if charge is multiplying, if it comes here, division will come. So potential difference is equal to work done divided by charge. So if the potential difference is given as 1 volt, indicates that how much work it has to do for pushing charges from here to here. How many charges also important for pushing 1 coulomb of charge from here to here. Okay, so for pushing 1 coulomb of charge from here to here, how much work it has to do, that is the theme here. So for pushing 1 coulomb of charge, okay, from this point to this point, it has to do 1 joule of work. That is what it means. So what does it mean now? It means that I'm going to write in sentence formation, explanation just now completed. It means that 1 joule of work is done in moving 1 coulomb charge from one point to another. So 1 joule of work is done in moving 1 coulomb charge from one point to another. This is the meaning of it. Okay, now we will see question number 3. So how much energy is given to, the question number 3 ma, how much energy is given to each coulomb of charge passing through 6 volts battery? So how much energy is given to each coulomb of charge? Each coulomb of charge, how much energy it is getting in passing through 6 volts battery? So 6 volts battery is there. So how much energy we should give to each coulomb, like that. So we are having again formula. What is that formula? Potential previous one only. Here we already wrote potential difference is equal to work done by charge, right? So I'm going to write that one only. Potential difference is equal to work done divided by charge. So how much energy is given each coulomb of charge is passing through 6 volts battery? This is what question they given, and we are going to write given data. So if you read carefully, already they give some data to us. For example, each coulomb of charge means they are asking us to consider only 1 coulomb. So that means I am going to consider charge 1 coulomb, because they are asking us to consider each coulomb of charge like that. So I am going to consider 1 coulomb only, and it passing through a 6 volts battery. So he is mentioning that a battery is there and the voltage is 6 volts like that. That means battery contains potential difference. So what is the 6 volts? 6 volts is nothing but potential difference. So they gave potential difference also. Potential difference is equal to 6 volts. And what we need to find now? How much energy? So how much energy we need to find now? Remember one thing, energy and work in numerical wise they are same only, but definition wise it will be different. How? For example, how much energy is there, that much of work you will do. So work how you are doing means because of energy. Energy is ability to do work. Okay, so for example, like a cell phone battery. In cell phone battery you are having 100%. So that 100% is energy, and how much work you will do until that 100% completed, right? So for example, if total 100% completed, energy completed, so how much work you did means 100% battery completed, that much of work you did. So for definition wise it will changes. How it will changes means energy is ability to do work, okay, while work itself you are doing something like that. Okay, so here asking there how much energy is nothing but if you find work done, that will also same only. So they are asking us to find energy which is nothing but work done. So work done is equal to question mark. So by using this formula, how you can write now? So again I'm going to rewrite this formula, or simply if you want you can remember this formula. If you want you can remember this formula. Work done is equal to potential difference into charge. The same formula we can write like this, right? So here I want work done only alone. So work done is equal to, here charge is doing division. If it comes this side, multiplication will come. Work done is equal to potential difference into charge. If it is doing division here, if it comes this side, multiplication, division, multiplication, like that. So potential difference, how much they give? 6 volts into charge, how much you need to consider? 1 coulomb you need to consider. So that is equal to how much more? So 6 joules of work you did. This is what the work done, that our energy. So how much energy is given to each coulomb of charge passing through 6 volts battery means you are giving 6 joules of energy to each coulomb of charge. Okay, this is what it means. Thank you guys.